In this video, I will be teaching you another extension in regards to the lesson about types of chemical reactions. To further enhance your knowledge from the previous video, we will be having 8 practice questions. So first, we'll start with number 1. So for the types of chemical reactions, our problem asks which type of chemical reaction this is. Let's check. I don't think there's any sort of displacement here, either single or double displacement. Um, it's not really affirmative to say if there is a combination or a decomposition reaction happening, since there are 2 parts in the reactant side and 2 parts in the product side. So we can't consider them as either combination reaction or decomposition reaction. Could it be said that it's acid neutralization because uh, we do have an H, but we don't have an OH as a base. Yes, we have an acid, but we don't have a base. Therefore, we can consider it as an acid, base, and R. Well, for combustion, it might be a combustion. Let's check. Again, our format for combustion reaction is CH plus O sub 2, arrow to the right, CO2, carbon dioxide, plus water, H2O. Do we see any similarity apart from the um, extra fat that we see from the chemical equation? I suppose so, because as you can see, there is CH there, O2, exactly O2, CO2 over there, H2O, exactly. Therefore, the chemical reaction for chemical equation number 1 is combustion reaction. There you go. Let's move with number 2. Let's analyze. 3 mg plus 1 Fe sub 2 O sub 3. One thing for sure is that 1 Fe sub 2 is equivalent to 2 Fe. They're just the same. They're written in different ways, but they're basically the same. Therefore, let's encircle those. Whenever you see from this time onwards, whenever you see this kind of symbol, it means it's an equal sign. But yeah, it looks a little weird, but that's how I'd be measuring whether or not these parts are equal to each other. Alright, we have O3. Actually, first we have 3 Mg, and we have O3 in the reactant. We also have O3 in the product side. This may just look like O sub 1, but I suppose not. It's O sub 3 because um, the 3 gives a distributive property, sort of a distributive property towards magnesium and oxygen. So, in that case, I think we can see something familiar here. It's a single displacement reaction. You might ask why. Technically speaking, our 2Fe used to have O sub 3, and 3 Mg used to be alone. But in the product side, 3 Mg now has O sub 3, which 2Fe once had, and now 2Fe is alone. So yes, there is a chemical swap that happened only once. Hence the name single displacement. Right, let's just square the final answers. Let's move on to number 3. Uh, so I think we can see now that we have 2 parts in the reactant side and just 1 part in the product side. It may look obvious now because another thing that you could see is we have water here, H2O. This is O sub 4 because we get O sub 3 from, assuming this is letter B. and this is letter A. And I think you know where this is going. This is the format of the reaction that we call the combination reaction. In other words, synthesis. All right. Um, yeah, I suppose that is all that we have to know for number three. It's just basic addition in terms of in scientific terms. A little you have to stray a little from the system, the mechanics behind addition in mathematics. Addition in science may be a little different, especially with chemical equations. All right, for number four, uh, we have hmm, let's encircle these. PO4, then one 1 Na sub 3 is equivalent to 3 Na. I hope you can see the pattern that I've been showcasing since earlier. It is understood that 1 Fe sub 2 is to Fe. Uh, 3 Na is equivalent to 1 Na sub 3. So please bear those in mind. Um, Also this, uh, 3H is equivalent to 1H sub 3. They're just the same. Um, we have Br, or bromine, I think. Um, It's not a cation or an anion, it's stable. It's a neutral element, I guess. Um, so right now, we're in the middle of a process. So let's say we have Na over here, and Na used to be together with Br, but now it has, in the product side, it now has PO sub 4, by which PO sub 4 used to be with H sub 3, by which H sub 3 is now with Br. May look confusing, but it's already pretty obvious. Number four is a double displacement reaction. So yeah, it's just similar to single displacement reaction, but the process is done twice. We swap twice in the same process at the same time. All right, for number five, uh, suppose it's pretty obvious. Let's say this is the product, and these are the reactants. So it could be said that this is already decomposition reaction. Why? Well, you might want to inspect the composition of the product. Let's see, 2PB. I think that's lead, if I'm not mistaken. I'm sorry, not really familiar with the periodic table just yet, but I'm trying my best. Uh, SO sub 4, SO sub 3. Hmm. Well, I think it's safely said that we have O sub 2. We combine that, we get SO sub 4. I'm not sure how it's compatible though. 3 plus 2 is 5, not 4, but anyways, if the process of computation may be a little confusing at times, especially when you're answering an exam in regards to this lesson, uh, to be more time efficient, it's better to resort to another possible way of determining whether or not this equation has a reaction that is considered a decomposition. And by that case, uh, AB is A plus B. I think that's just decomposition, period. That's it. For number six, uh, let's see. We have 3 calcium. SO sub 4. It's just a different color. There you go. Um, Again, 1 Al sub 2 is 2 Al, in other words. Therefore, 2Al, and they're the same color. Uh, hmm. Oh yeah. OH is just a different color. OH sub 2. Basically, it's now OH sub 3 because 3, again, the coefficient in mathematical terms serves as a provides distributive property to its nearby. I'm not sure how we call these, but I hope you're getting my point. Um, we read this as 3Ca and 3OH. So OH sub 3 is equivalent to 3OH. Please note that. Alright. Um, 3 calcium used to hang out with OH sub 3, but then now it hang out with uh, SO sub 4. 2 aluminum used to hang out with SO sub 4, but now aluminum hang out with the former partner of 3 calcium. It could be said that reaction here is um, double displacement. Okay, let's move on to number 7. It's pretty obvious now. We have product and 2 reactants, AB, then A plus B. You know the drill. This is decomposition reaction. Let's further investigate why to strengthen or to fortify, solidify our proof to that this equation is decomposition reaction. Um, let's use violet. Calcium, then O sub 3 plus another O. I'm sorry. O sub 3 is the product of O and O sub 2. And we get carbon from carbon. So yeah, that's it. Decomposition. Let's move to the last example. Yeah, I cannot really consider this as an example or a practice question. We're answering it together after all. Uh, yeah, we're answering it together. For number 8, let's see. By the way, 2 Fe sub 2 is 4 Fe. Please note that. So therefore, these are equal to each other. Uh, 3 O sub 2, this is the same as O sub 3. Then 3C, we get also 3C at the other side. Well, 4Fe used to hang out with O sub 3, but now also O sub 3 hang out with 3C. Therefore, 4Fe became single. There's nothing to um, put with it together. So this is considered a single displacement reaction. Finished. We finished the practice questions. That's it for this video. Let's just recall from numbers 1 to 8. Number 1, combustion reaction. I have my answer key right now. That's correct. Single displacement, correct. Number 3, combination reaction. In the word synthesis, correct. Double displacement reaction. Decomposition, number 5. Number 6, double displacement. Number 7, decomposition reaction. Number 8, single displacement reaction. That's correct. Alright, that's everything that you have to know for this video. Thank you for answering with me. May this video help you in your science lessons, especially regarding chemical reactions. Thank you for watching.